Good morning, ladies and gentlemen, and welcome to the course on Managed Aquifer Recharge Systems and Water Harvesting Techniques promoted by the University of Sassari and the European Commission within the framework of the MAIA project. This is Enrique Fernández Escalante, Doctor in Hydrogeology. In the first lecture, we'll talk about the hydrodynamic mechanism of Managed Aquifer Recharge, some general and specific concepts, examples, exercises, and further references. There are several definitions for MAR, for example the one from UNESCO, increase of the natural groundwater recharge into the aquifers, or the one from Bauer, to increase the available groundwater resources and to improve the quality of the groundwater. Whatever be the definition, the most important in my opinion is the keyword intentional. MAR is performed by men, and these figures represent how important this technique is. The idea is quite simple. We introduce water either in a point, a line, or a polygon. This water progresses across the unsaturated zone until it reaches the groundwater level, and this water already stored is extracted whenever be necessary, either from the same point or from another well or borehole or whatever. Regarding the hydrodynamic mechanism, there are different formulas, being the most important perhaps Darcy's law, which is a simple mathematical statement which summarizes groundwater flowing into aquifers. It's necessary a pressure gradient. It is not for hydrostatic conditions. The greater the pressure gradient is, the greater the discharge rate. The flow rate of groundwater will be different through different materials. 60 years after Darcy, Green and Damt proposed a new formula for unsaturated means, in which infiltration rate was function of the capillary suction capacity or negative pressure around the humidification valve. This equation does not consider the dissolved air, then the result is underestimated. The phi parameter must be calculated for realistic situations. Later, Kosteikov proposed a new formula for the infiltration rate, which is function of the time of the tests and two empirical parameters, B and M. The formula is valid either if there is no addition of water during the infiltration test or there are reposition volumes. It is also usual the use of the Hefele infiltration test. The first phase of the hydrodynamic mechanism is the formation and advance of the humidification valve. The second, the bulging of the piezometric surface, where the humidification valve moves across the unsaturated zone with a flow not exactly vertical due to the phi parameter of Green and Damt. The recharge in a stable regime can work either in vertical control or in lateral control when the variation of the storage is zero. Finally, when MAR ceases, the crest of water disappears. Some other key concepts are the safe yield, a technical and philosophical concept original from Finnish, in which the inflow is exactly the same as the outflow. The multifunctionality is also important, or diversification of water origin, what allows applying the recommendation dilution as a solution to pollution, what means that you can combine different waters from different qualities in different doses. And also it's important to remark technical solutions or sustainable managed aquifer recharge technical solutions. For example, don't close a well, reuse it. A collection of 73 are published in the references at the end of this lecture. The capability of MAR technique is to store water in aquifers, smooth out fluctuations on demand, utilization of the aquifer as a regulating reservoir, reduce evaporation losses, compensate the loss of natural recharge, soften qualitative differences, and thus saline water intrusion barriers, purification of urban wastewater for reusing, avoid geotechnical problems, economical improvement of depressed areas, and intervention against desertification, soil erosion reduction, etc. The origin of the water for MAR may be very diverse, either from rivers or canals, perennial, intermittent streams, dams and ponds, wastewater treatment plants, desalination plants, urban runoff water, reclaimed or treated water, irrigation returns, accidental recharge, etc. Some of the usual problems when performing MAR activities are the poor knowledge of the receiving medium, the inappropriate design of MAR facilities, the use of water of poor quality, the natural losses of water stored in aquifers, the environmental impacts downstream, some other negative impacts caused by experimental devices, socioeconomic and political problems, insufficient dissemination and information of the results, and of course logging. Some examples and cases of interest for surface MAR facilities are the infiltration ponds, the most usual MAR facility in the world. This is an example from Ica, Peru. Canals and ditches, also very spread all around the globe. Irrigation and MAR canals, for example the Careas from ancient times. And for deep MAR facilities, it is usual the use of wells, boreholes, and barriers or batteries for injection wells. MAR is also used to combat saline water intrusion by means of hydraulic positive barriers. And there are abundant examples for MAR in arid and semi-arid climates, for example this dunar system restoration and the combination of check dams and MAR wells. The most normal use of MAR water is for irrigation. There are permanent improvements in water energy nexus and groundwater secure storage. And MAR is also used for wetlands restoration, with abundant examples all over the world. Eventually, MAR is also used for urban water supply, increasing the water supply guarantee and decreasing the climate change threat. MAR with reclaimed water is usually called SATMAR, is a technology for depth injection of reclaimed water by means of bores and wells, in general located close to the wastewater treatment plants where water is diverted. It is subjected to concession and requires an ambitious quality. So, in short, MAR technique presents more pros than cons. It is usual to find problems during the interpretation of infiltration tests. This is why we have proposed a set of 3 different exercises applying 3 different methods. It's important to note that infiltration rate will decrease along time due to clogging. Clogging will occur, and an accurate infiltration test duration for MAR lasts maybe 1 year. In the first exercise, we are going to use Darcy's law to calculate the infiltration rate from the data collected from the Haefel infiltration test displayed in this template. The second exercise exposes a collection of data gathered from an infiltration test, and we will calculate the infiltration rate applying the Kostyakov formula. And in the third exercise, we'll use the green and damped formula to calculate the infiltration rate, also from the data exposed in the template here displayed. And as additional materials, there is a collection of 7 references in which you can improve the knowledge already acquired during this lecture, reminding that in my project website there is an extended version of this presentation. Good luck with the exercises. See you next week.